Thank you for the presentation opportunity. I'm happy to represent Tupy today. I'll talk today about the need to activate effective, fast decarbonization paths. We had a net revenue of 10.2 billion reais in 2022, with an EBITDA of 1.3 billion reais. We generate 70% of our revenues on foreign markets, offshore Brazil, in more than 40 countries, and we employ more than 19,000 employees in our 3 facilities in Brazil, 3 facilities in Mexico, and we make castings of high geometrical and metallurgical complexity. And this company started making pipe fittings in the 30s. In the 50s, we start making castings for passenger cars, for suspension and braking components. And then in the 2000s, we moved the business towards capital goods. So we start making structural castings for different machinery, transportation, equipment, construction machinery, and agricultural machinery. The main products are still engine blocks and cylinder heads, but we make all types of different structural components for this type of applications. We supply a variety of parts to different capital goods producers. Our customer products have significant impact to improve life quality of people. We have 3 plants in Brazil, 2 in Mexico, and 1 in Portugal, with a strong presence to global markets as North America and Europe. Our position provides advantage to combine access to clean energy as well as local content supply. Tupy is an 85-year-old company, known by its global competence for cast iron parts. However, we have enlarged our portfolio on complete machined parts and assembling of full engines. Several other diversification paths are being explored to support the decarbonization in a broader aspect than transport. As mentioned before, our recent acquisitions allow us to go further on value added to our customers, from castings to full assembled engines. One's future will be multi-energy. Supporting our customers on the transition is strategic, including the capacity to support the development steps with our engineering services. Now let's talk about challenges for humanity. Our world has 2 very big challenges: inequality and climate change. From an inequality point of view, energy consumption is a strong part of that, which can present the life expectancy in the yellow circles in poor countries to be 10 to 15 years lower than developed countries. Notice that per capita energy consumption present large differences as well, being 10 to 20 times higher on developed countries. The result is that energy consumption and CO2 emission levels should be strongly concentrated in developed nations. Then, restrict the access of energy on poor or underdeveloped countries is not a path to reduce inequality. Besides life expectancy, there are several other demands in society that will also increase the energy demand. By 2040, it is estimated the increase of more than 30% primary energy to be consumed than today. And such demand increase does not count a significant reduction of inequality. When we talk about energy, we cannot forget that it is strongly linked to effective CO2 emission. So, at the same time, the energy demand increase needs the access to clean energy sources. Looking to historical data, we can be happy to the improvement we got out of energy efficiency, reducing in percentage our annual increase of energy demand from 2.3% per year to 1.3% per year. However, in terms of CO2 emission, it is important to check the portion of renewables compared to fossil energy. From 2010 to 2021, primary energy outlook, we saw an extraordinary increase of renewable energy generation. However, its increase is equivalent to 1/3 of the energy demand increase in the period. That results in absolute increase of fossil energy consumption. So, we need to rethink this model and help decarbonization with additional actions in short and medium term. It is possible to indicate 4 steps of activities to help decarbonization. Number 1, use existing technologies to promote higher efficiency levels. Number 2, there are plenty of energy sources being wasted, and we have to evaluate the best use of them. Number 3, even inside fossil fuel options, there are significant decarbonization steps possible to be taken to achieve a much more reasonable level of CO2 emissions. Finally, we need to continue investments on research to support bolder steps afterwards. Starting on efficiency to reduce fossil fuel consumption. Comparing with today, we had a very good improvement in efficiency over the last decades. However, even today, there are best practices not mainstream yet. Only with that in focus, we can reduce fossil consumption in a very fast pace. It is not only in transportation, but also in buildings, computing, waste management, food, and so on. The efficiency work can also be extended to the areas of logistics. There is always a discussion indicating a dilemma between food versus fuel, which is not realistic. Today, the level of food wasted is much higher than the level of people with no access of regular food supply, about 10 to 20%. Improvements on logistics could reduce energy consumption, reduce CO2 emission, and improve social inequality. As presented last year here in the Vienna Motor Symposium, we developed the combination of high-resistance material with thin wall casting process to enable the transformation of structural parts from aluminum to cast iron, what we call the ultralight iron technology. We use as a demonstrator the block of a serious passenger car achieving same weight with improved stiffness, less CO2 emission, and also lower costs. A similar approach is being used on other parts like engine heads, gearboxes, and clutch housings. Moving now to boost the use of clean energy available, it is possible to indicate that there are several clean energy options. Depending on the countries, more favorable conditions can be explored locally or globally due to the availability of natural resources. Using Brazil as an example, we can see several chances of energy generation that can not only decarbonize the country, but also help other countries through exporting. Notice that all this potential is not considering the increase of land use or technology improvements yet. Tupy is a leader in Brazil to provide full solutions for transforming organic matters into biogas and biomethane, as well as using it in gensets and trucks. We support the complete design of the facility, including its operation. We are also installing complete systems to support farms to decarbonize its residues in the production of biogas and biomethanes. It enables also the production of biofertilizers. However, not only clean energies play a role in fast decarbonization process. We need to separate different fossil fuels properly by its carbon intensity. Notice that even inside fossil, it is possible to achieve significant decarbonization levels. That should be in consideration for an effective transition. Natural gas in areas with clear access to that should play a major role. Another important aspect of natural gas is the possibility to assure supply for applications using biomethane while its production is being increased. In a similar perspective on transport, we can see the use of natural gas or biomethane as a strategic step to enable fast decarbonization and support the infrastructure transition to gaseous fuel at the same time. In the last point, but equally important, we cannot reduce the R&D investments on future disruptive technologies once they are critical to long-term decarbonization. Several technologies are on radar for decarbonization. However, they are not mature for short-term applications, or its use now can generate higher emissions in some conditions. Investments need to continue to allow more flexibility and higher impact on decarbonization routes in the future. As well, some of these technology solutions demand infrastructure to make them effectively clean. For example, we all know that electrification in transport is a very important path for decarbonization. But depending on the vehicle type and size, it can be much more critical to the environment. Regarding battery size, the electric vehicle carbon footprint using clean energy electricity on operations can take 3 to 5 years to reach the same level of an equivalent vehicle in combustion. That is linked to the big carbon footprint to produce the batteries and also do the mining. There are other impacts on natural resources like water and land use. In terms of total life CO2 emission at light vehicles, biofuels present much better and faster decarbonization potential nowadays, while battery production cannot be completely clean. That is the reason as well that hybridization sounds a strategic path in short and medium term to help decarbonization. On commercial vehicles, the use of hydrogen is another strategic path with very important focus. At Tupy, we have under development a clean and high efficiency process to recycle batteries out of electric vehicles. It will support the decarbonization of battery manufacturing, which is critical today, as well as support mineral supply that can become short soon. We are implementing a demonstration plant in Brazil by early 2024, and later to spin off this plant concept internationally as customers will demand. Our patent recycling process has the novelty to allow hydrometallurgy process to operate flexible with different battery chemicals in the same batch, allowing improvements on productivity, enhancing cost competitiveness. On hydrogen combustion engines, Tupy is collaborating with AVL and Westport on the development of a demonstrator engine using high-pressure direct injection system in a transformed series diesel engine to achieve more than 50% brake thermal efficiency. In parallel, there are evaluations with different institutes to study hydrogen embrittlement mechanisms and influence on cast iron alloy for hydrogen combustion engines. It is fundamental for an effective design of alloys and testing methods to assure same durability than diesel engines. And now our conclusions. Energy is critical for life quality, and we cannot restrict its increase to the most vulnerable and developing nations. However, we need to put in action all possible solutions for a fast decarbonization. That's the reason we came with these priorities. Number 1, energy efficiency with existing solutions. Number 2, access all types of clean energy. Biofuels like ethanol and biomethane must play a significant role. Number 3, even on fossil, to favor low carbon intensity as natural gas as an example. On R&D, to keep investments to mature technologies and infrastructure to get effective clean solutions on the entire life cycle. And we cannot forget that legislation is an important place to enforce such paths, and that cannot restrict the evaluation scope different than life cycle approach. Thank you again for your attention.